Hello everyone, I am Anil Bharate from Department of Computer Science and Engineering, BLDA CET, Vijaypur. In this video, I am going to explain part of module number 4, that is principles of counting. Again in that, principle of inclusion, exclusion. Okay. Now let us say S is a finite set and this cardinality of S is number of elements in set S. It is also called as order of set or size of set, or as I said, it is cardinality of S. Then order of A union B will be, that is number of elements in A union B is given by number of elements in A plus number of elements in B minus number of elements in A intersection B. Okay. Here we are including all elements of A, but we are excluding common elements of A and B. That's what include and exclude. Now let us say that if A is complement of A, complement means, say if set union set is having 1 2 3 4, then if A is 1 comma 2, then A complement is nothing but 3 comma 4. That is the total number of elements, elements of A, sorry, number of elements, elements of U minus elements of A. So we take away or we neglect these elements from U which are there in A, and remaining elements will be in complement of it. So let us assume that A bar is complement of A and B complement of B. Then we have one more standard formula or result, that is complement of A intersection complement of B is equal to complement of A union B. Okay. Therefore we can write A union B, complement of A union B is equal to number of elements in S minus number of elements in A union B. Then by using this above first result, we can write A is complement union, intersection B is complement, that number of elements in it will be number of elements in complement of A union B equal to S number of elements in S minus number of elements in A union B. So standard result we can have is number of elements in A and A union B, and its complement is nothing but number of elements in S minus number of elements in A minus number of elements in B plus number of elements in A intersection B. Now this is called as principle of inclusion exclusion. Now that was for only say one set. The principle of inclusion exclusion for n number of sets we have it. Let us assume that S is a finite set, A1, A2, A3 up to En, they are subsets of S. Then principle of inclusion exclusion states that for n sets, it says that union of all the elements of A1, A2, A3 up to An is equal to summation of number of elements of Ai. It means that we take only single element from each set, then minus summation of A intersection Aj. It means that we take two sets at a time, maybe A1 intersection A2, then A1 intersection A3 and so on, but combination of 2, next plus combination of 3 minus plus. So if you observe one more thing, we have alternate plus and minus symbols. Now this is one more result, that is intersection complement of intersection of A1 A2 up to An is equal to total number of elements in S minus the remaining same thing. I'll take one example, then it will be more clear for you where to apply this formula and all. Let us assume that in a hostel there are 12 students who study only mathematics. Okay, there are 20, and let us denote it by A. The students who study mathematics will be denoted by A, or they belong to set A. Then we have 20 students who study only physics. Okay, physics is, let us assume it, or denoted by B. Then there are 20 students who study only chemistry, and there are 8 students who only study biology. Now there are 5 students who study both subjects, or two subjects, A and B. So it is nothing but A and B, A intersection B. Similarly, A intersection C. So we have so many students. The list of students is given, and in front of that, what subject they are going to study, it is also given. So let us write somewhere. So first is 12 students who study only mathematics. So I can write how many students who study only mathematics, 12. So cardinality of A is nothing but 12. Similarly, cardinality of B. Let us see how many students read only B subject. B here is nothing but physics. So 20 students. 20 study only B. So let us go for next. Next is again 20 who read this is subject C, or chemistry. Cardinality of C is equal to 20. Now similarly, what is cardinality of D? It is 8. Here it is. 8 students only study biology. So here I can write cardinality of D as, sorry, how much was it? 8. Okay. Now let us consider combination of 2's now. Now 5 students study A and B. So A intersection B is 5. Now next, 7 is nothing but A intersection C. A intersection C is 7. Then we have A intersection D as 4. A intersection D is nothing but the number of students who study both subjects A and D. Here A means mathematics, D means biology. A and D is 4. The next is 16. B and C. B and C is 16. Then B and D, next BD, B and D 4. B and D 4. Next we have this C and D 3. C and D is 3. Then we have, yes, we have combination of threes next. We completed combination of ones and twos, now 3. A, B, C, the students who study these 3 subjects, A, B, C, it is 3. So I will consider combination of 3, A, B, C, it is given as 3. This is given data. Here it is. Next 2 is for A, B, D. Then A, B, D. 2. We are done with this. Then B, C, D. B, C, and D. It is 2. B, C, D is 2. A, C, D. A, C, D. That is intersection of all these 3 is A, C, D is 3. We are done with combination of 3's. Now let us say, let us see how many students are there who study all 4 subjects. There are 2. It is given data. 2 students study all these 4 subjects. Means that A intersection B intersection C intersection D is 2. Okay. And there are 71 students who do not study any subjects. So can write, who do not study means complement of A and complement of B and complement of C and complement of D. So this is 71. That is, these many students, they do not study any of these subjects. So it is 72. Now we can make use of inclusion exclusion formula or principle to solve this problem. The question is find total number of students in the hostel. So you are asked to find out cardinality of yes in that formula. Now what we can do is we can apply the formula, which is a1 a2's complement intersection a3's complement, so on up to say an, cardinality of S minus combination of one element plus then combination of two AI and AJ and so on. So what I can do, so this is already given, it is 72. Actually this A intersection, A is complement intersection, B is complement intersection and so on, it is 71 not 72, so it is 71. Okay, so this is nothing but four subjects, and that is A intersection, B intersection, C intersection, D. Now yes minus combination of one means A plus B plus C plus D, then plus then combination of twos now, that is A intersection B plus A intersection C plus, let us see what are the combination, AC AD, then we have A intersection D, then we have B intersection C, then B intersection D, then we have C intersection D. Then this is minus, this is plus, then we have minus, and now we consider combination of three elements, that is these four, ABC and so on, and finally here we consider combination of threes plus combination of fours. So let us write directly, this is given 71, this is unknown quantity, minus combination of ones means, so let us consider this cardinality of A, B, C, D individually. So what I can do, 12, 20, 30, 20 and 8. 12, 20, 20 plus 8. Next plus, then combination of twos and addition of it. So all these 5, 7, 4, 5, 7, 4. Then we have 16, 4, 3. 16, 4, 3. Then next minus combination of threes. Here 3, 2, 2, 2, 2, 3. 3, 2, 2, 3. Then plus combination of fours. Is only one, that is 2. So we have 2 here. So 71 as it is. So if you solve all these things, you will get cardinality of S as 100. So I can say that there are totally 100 students in the hostel. This can be done by using inclusion exclusion principle. Thank you.